All right, hello and welcome. Today we are jumping right into the world of algebra, and we're going to tackle something that can look, well, a little wild, polynomials. But don't you worry, because by the end of this, you'll have all the skills you need to totally tame this mathematical beast. So when you first see something like this, right, it can honestly look like some kind of secret code. All those numbers and letters and the tiny little exponents, it can feel pretty intimidating. But our mission today is to crack that code, and I promise you, it is way easier than it looks. So here's our game plan. We're going to start with the basics. What even is a polynomial? Then we'll get into the one golden rule you absolutely need to know. After that, we'll walk through adding, then subtracting, and then we'll put it all together. Let's get into it.
Okay, first things first. Before we can tame this beast, we've got to understand it, right? We need to know what it's made of. So let's break it down into its most basic parts.
So, what is a polynomial? Honestly, don't let the fancy name scare you. It's really just an expression made up of a few different parts. I like to think of it like a train, where each car, we call them terms, is just linked together by a plus or a minus sign. And each one of those terms, those train cars, is made of three super simple parts. You've got the coefficient, that's just the number out in front. You've got the variable, that's the letter, and you've got the exponent, that's the little number up top, the power. That's it. Every single part of a polynomial is just some combination of these three things.
Okay, now for what is maybe the most important part of this whole explainer. If you only remember one thing today, make it this. There is a golden rule that unlocks absolutely everything, and it's all about something called like terms.
You've probably heard this before, right? And it is the perfect way to think about this. I mean, in the real world, if you have 7 apples and I give you 2 more apples, you have 9 apples. Simple. But if I give you 2 oranges, you can't just mash them together and say you have 9 apple oranges. No way. You have 7 apples and 2 oranges. Math works exactly the same way. And this slide just breaks it all down. For terms to be like each other, they need to have the exact same variable and the exact same exponent. The number out front, the coefficient, it doesn't matter at all. That's why 7x squared and negative 2x squared are like terms. They're both x squareds. But 7x squared and 7x? Nope. Their exponents are different. This one little rule is the key to everything else we're about to do. Okay, now that we've got the golden rule in our back pocket, let's actually put it to work. We're going to start with addition, which is the perfect warm-up. And look, the process is super straightforward. First, you just find and group your like terms, all your apples together, all your oranges together. Then you just add or subtract the numbers in front, the coefficients. And here's the crucial part. The variable and the exponent, they don't change. They just come along for the ride. Let's see it in action. You know, lining up the terms vertically like this can be a total game changer for keeping things organized. You can see we're just doing really simple addition down each column. For the x squared terms, 3 plus 2 gives us 5. For the x terms, 5 minus 3 is 2. And for the numbers without a variable, the constants, negative 2 plus 7 is 5. And boom, our final answer is 5x squared plus 2x plus 5. That's all there is to it. All right, you've totally mastered addition, so let's level up to subtraction. Now, there's one little twist here, but once you see it, it's just as easy. The only thing you have to do is watch out for the sneaky negative sign. This right here, this is the entire trick to subtraction. That minus sign sitting between the two polynomials, it's a signal. It's telling you that you need to distribute it, which is just a fancy way of saying you have to flip every single sign inside the second set of parentheses. A positive becomes a negative, and a negative becomes a positive. So our new steps look like this. Step 1, spot that negative. Step 2, and this is the most important part, you apply it to every single term that comes after it. Once you've done that, the problem totally transforms. It's not even a subtraction problem anymore. It's just an addition problem, and you already know exactly how to do that. Let's watch how this works. See that minus sign? It makes that whole second polynomial do a flip. The positive 2y squared becomes negative, the positive 6y becomes negative, and the negative 5 flips to a positive 5. After that one little step, it's just addition again. We combine our like terms and we get 5y squared, negative 10y, and positive 14. Perfect. Okay, you have the definition. You have the golden rule. You've handled both adding and subtracting, so you know what that means. It's time to put all your new skills to the test with our final challenge. Now, this one might look a little trickier, maybe because we have 2 different variables, a and b. But guess what? The rules don't change, not one bit. We're going to follow the exact same steps. So, what's the very first thing we should be looking for? You got it, the sneaky negative. Since this is a subtraction problem, our first job is to flip every single sign in that second polynomial. So 2a cubed becomes negative, negative 5ab becomes positive, and positive 3b squared becomes negative. Okay, now the problem is ready to solve. Now we just go on a little hunt for our like terms. We group up the a cubed terms, then we group up the ab terms, and yes, they're like terms because the variables and exponents match, and finally, we group the b squared terms. Look at that. It's all organized and ready for the final step. And there is our answer. 4 minus 2 is 2, so we've got 2a cubed. 2 plus 5 is 7, which gives us 7ab. And negative 1 minus 3 is negative 4, so we have negative 4b squared. The beast is officially tamed. Seriously, just take a moment. That expression that looked so complicated and messy at the beginning is now something you know exactly how to handle. And this isn't just some random math skill. Polynomials are used to model everything from the path of a rocket to trends in the economy. You've learned the rules, you've seen the tricks, and you've officially tamed the polynomial. So to wrap it all up, don't ever be intimidated by these things. Just remember that polynomials are made of simple little pieces. Always, always follow the golden rule of combining like terms. And if you're subtracting, just remember to flip the signs first. You've absolutely got this. You know, you didn't just learn how to solve a specific type of problem today. You learned a method for taking something that looks really complex, finding the rules that govern it, and applying them step by step. That's a skill you can use absolutely anywhere. So the only question left is, what beast are you going to tame next?